Okay. So for first one, two, we have 551. Here we have 173. And we needed to make look as t is 11, 17, 5. So in order to do that, we put our scalar for a1 as 2, and our scalar is 1 for b1, and that should give us t, which is 11, 17, 5. And for the next one, we need t to be 12, 24, 8. So if we put the scalar to -2, this should give us 12, 24, 8. Then for the third one, it goes back to being the regular one because our W, since we added it, but it's theta, so it's 0, 0, 0. So it should still look the same as our first one. And for our second one, it should also be the same, where should be scalar 2, scalar 2. There we go. This one should give us 12, 24, 8 as well. So the same. This one should be same for the second one and the fourth one. Now for the fifth one, we have 551 as U, 10, 10, 2 as V, our W is 173, and our T needs to look like 6, 12, 4. So in order to do that, have our scalar for the first one as 1. Our scalar for the second one is going to 0. And for our third one, it's just going to be 1. Go. That one is 6, 12, 4. So for the second part, which is number 2, we need our vector to be 7, 19, and 7. So in order to do that, our U, I used 1, 9, 1. Yes, and then for vector B, for B1, I use 6, 6, 6 is, oh no, sorry, I use 5, 1, 5, 5, 1, 5. So the scalar for the first vector is 2. The scalar for the second one is -2. And then this should give us our result of 7, 19, 7. And then for B, our ending result needs to be 4, -2, -2. So for that one, on vector A, I use 8, 5, 5 with a scalar of 2. Then the second one, I use 6, 6, 6 with a scalar of -2. And then this should give us our result of 4, -2, -2. And then for number C, our end result needs to be 4, 11, 20. So for vector A, I use 1, 5, 9 with a scalar of 2. For vector B, I use 2, 1, 2 with the scalar of 1. And then I, oh, here we go, better representation. I took out the predetermined U and V, so this one should be better. And for our last one, our result needs to be 7, 12, 20. So in order to that, I use 7, 2 with a scalar of 3. And then our second vector, I use 3, 7, 3, the scalar of -2. And that should give us 7, 12, 20. Wondering where my C went because it disappeared. There we go. So for the last one, since it was predetermined vector, there we go. That's the one where I used 3, 7, 3 with a -2 as a scalar, and then I used 7, 2 with 3 as a scalar. But overall, I guess what we can use, well, I guess what I learned from the activity is how to like, how the scalar affects the way you can find, I guess, your last vector or the addition. So working backwards, I was like, all right, what's the scalar that I need to use to determine the addition will result as the vector that we need? And then what ideas do you think this demonstration site can be used for and why? I guess just to represent vectors and like how each point is different. So when we have like there we go. Like if we put for any, I put a lot. That makes sense. So each point is just like the distance from like the additional points. So each one is the same distance from each other, same distance from up and down, and diagonal as well. So it's just to visualize vectors. That's how it can help us. The program's a little confusing, but I mean, I guess with practice, it would be easier to be able to maneuver it to see like what things it can use. And eventually it'll just be easier to like visualize vectors. So I guess like when we're doing our work in class, this will help us visualize like the direction and like the dimensions that we're using. So like which direction vectors are going. Yeah.